Hi, welcome to T2G channel. In the channel, we will video 12th standard second midterm physics important 2 marks, 3 marks and 5 marks question. First 2 marks question. State Huygens principle. Next, what is double refraction? Next, list the uses of Polaroids. Next, what are the uses of X-rays? Next question, define threshold frequency. Next, list out the characteristics of photons. Next, the radius of the fifth orbit of hydrogen atom is 13.25 Armstrong. Calculate the de Broglie wavelength of the electron orbiting in the orbit. Next one, define impact parameter. Next, state Malus law. Next, two independent monochromatic sources can never be coherent. Why? Next, define stopping potential. Next one, calculate the distance up to which ray optics is a good approximation for light of wavelength 500 nanometer falls and an aperture to width 0.5 millimeter. Next one, write down the four properties of photons. Next one, what is called a continuous X-ray spectra. Next, how many photos per second emanate from a 50 MW laser of 640 nanometer. Next, state Brewster's law. Next, what is called a Fresnel's distance. Next, what is myopia? What is the remedy? Next one, what are the shapes of wavefront? First, a source at infinite, B point source. Next, what is the diffraction? Next one, find the polarizing angles for glass of refractive index 1.5 and water of refractive index 1.33. Next, define work function of a metal, give its units. Next, calculate the momentum and the de Broglie wavelength of an electron with kinetic energy 2 eV. Next, what is Bromstein-Hahn? Next, state Bromstein's law. Next, define stopping potential. Next, what is Bromstein-Hahn? Next, the radius of the fifth orbit of hydrogen atom is 25 Armstrong. Calculate the de Broglie wavelength of the electron orbiting in the fifth orbit. Next, define atomic mass unit. Next, define curated. So, what do you mean by doping? Next one, 3 marks question. First one, state and prove Brewster's law. Second, a diffraction grating consists of 4000 slits per centimeter. It is illuminated by monochromatic light. The second order diffraction maximum is produced at an angle of 30 degree. What is the wavelength of the light used? Next one, differentiate between Fresnel's and Fraunhofer diffraction. Next, derive the expressions for the de Broglie wavelength of electron. Next one, give the application of photocell. Next, calculate the cutoff wavelength and cutoff frequency of X-rays from an X-ray tube of accelerating potential 20,000 volt. Next, write the properties of cathode rays. Next, write down the drawbacks of over-atom model. Next, explain the characteristics X-ray spectra. Next, compare diffraction and interference. Next, state MLBS law. Write its equation. That is Marks law. Next one, a microscopy has an objective and eyepiece of focal length 5 cm and 50 cm respectively with the tube length 30 cm. Calculate the magnification meter at near point. Next one, enumerate the photoelectric effects of law. Next, define work function, stopping potential. Next, what is the photocell? Mention it type of cells. Next, why we do not see the wave properties of a baseball. Next, what is Fresnel's distance? Obtain the equations for it. Next, list out the photoelectric effect. Next, write a short notes on prosphobia. Next, a radiation of wavelength 300 mm is instant on a silver surface. Will photoelectron be absorbed? A function of silver 4.7 eV. Next, list out the laws of photoelectric effect. Next, derive an expression for the de Broglie wavelength of electrons. Next, write down the postulates of Bohr atom model. Next, a person has phosphidness with the fair distance he would see clearly is 75 cm. Calculate the power of the lens of the spectacles needed to rectify the defect. Next, discuss the spectral series of hydrogen atom. Next one, explain the idea of carbon dating. Next, distinguishing between intrinsic and extrinsic semiconductors. So, next 5 marks questions. First one, obtain the equation for path difference and bandwidth in young double slit experiment. Second, describe briefly the Action-Germes experiment which demonstrated the wave nature of electrons. Next one, obtain Einstein photoelectric equation with the necessary explanation. the J.J. Thomson experiment to determine the specific charge of electron. Next, explain about compound microscope and obtain the equation for the magnification. Next, discuss the spectral series of hydrogen atom. Next, state and derive radioactive disintegration law. Next, what is X-rays? How do we obtain characteristic X-ray spectra by explain with the transition levels? Next, explain how frequency of incident light varies with the stopping potential. Next, obtain the equation for resolving power of microscope. Next one, by Huygens principle, explain and prove law of refraction. Next one, explain Davinson-Germer experiment with the neat diagram, which demonstrated the wave nature of electron. Next, explain near point of focusing and normal focusing magnification. Next, state and prove Brewster's law. Next, discuss about astronomical telescope. Next, explain the effect of potential difference and photoelectric current. Next, explain the principle and working of electron microscope. Next, discuss about astronomical telescope. Next, draw the circuit diagram of a half-wave rectifier and explain its working. Next, describe briefly Davinson-Germer experiment which demonstrated the wave nature of electron. Next, mention the different types of photocells. Give the application of photocells. Next, obtain the law of radioactivity. Next one, describe the working of nuclear reactor with a block diagram. ஸோ இதில் இருக்கக்கூடிய 2, 3 and 5 மார்க்ஸ் கொஸ்டின்ஸ் எல்லாம் நல்லா ப்ரிப்பேர் பண்ணிக்கோங்க. இந்த வீடியோ பிடிச்சிருந்ததுன்னா லைக் பண்ணுங்கள், ஷேர் பண்ணுங்கள், கமெண்ட் பண்ணுங்கள் அண்ட் சப்ஸ்கிரைப் பண்ணுங்கள். தேங்க்யூ ஃபார் யுவர் வாட்சிங்.